Thank you. I'm going to be going a little fast today because this is a talk I gave last month in Australia that was 45-minute slot. So I'm going to cut down. So anything I skip over that doesn't seem clear, either ask me afterwards or come find me in the hall or something like that. Like I said, I work for Rackspace. I work as a Python developer. I was one of the original OpenStack developers, and now work building the SDKs for Python for OpenStack. If you need to contact me, I'm just ed.leafe@Rackspace or ed@openstack.org. And I'm on G+ and Twitter, so just my name, easy to find. Before I go ahead, what I want to do is I have a script that I'm running to illustrate this. Oh, let me get the resolution fixed. Get that down a little bit. Okay. All right, what this is doing is I want to check, make sure it works because the wireless here, okay, it's working. Wireless here is a little flaky in this room, so I've had this die in the middle, so I'm going to apologize in advance if it doesn't. Let me scratch that down. Good. Okay, so that's going to run. It's going to take a few minutes, so I'll go back to the talk. And then I'll talk about what that script is doing while it's running. Okay, so we're all developers here. We've all had these great ideas or just inspirations. We've created great apps, and we want to share them with the world and make millions of dollars, of course. So the problem is that once you have this and you write it on your own machine, at some point you have to deploy it. You have to get it out there. So you have to start dealing with the infrastructure for your application server. And the first thing you do is find a spare box, put your app on there, point the DNS to it, maybe point it to a database or something like that, and let the internet at it. And this works great, except that since I did mention it was an awesome app, pretty soon that box is overly stressed. So you come up with what ends up being like a very basic design. You throw the servers behind a load balancer, point the DNS to the load balancer, and now you're able to scale horizontally. And this works out really great because now you can share the load across these different servers as more and more people realize how awesome your app is. The one issue with that, and I guess kind of ties into the previous talk, is how do you get these app servers to all be identical, to all perform the same, to all have all the dependencies and deployments? You have to configure them. Usually, there's things like the Fabric scripts or Puppet or Chef or Ansible, Salt. All those things are designed to work on that problem. But what would be nicer is if you could take a snapshot of the server in the state you want it and then just copy that. So the other part of the problem is hardware. You have to deal with the hardware. I mean, I'm a software guy. I'm not really a big hardware fan. So question, how many software developers does it take to change a light bulb? Exactly, none. It's a hardware problem. Guy, I like how you think. All right, but even if you do deal with hardware, you start out with this vision of how things are going to be, and it doesn't always work out that way. My company asked me to disclaim that, no, this shot was not taken at a Rackspace data center. So. Okay, so wouldn't it be great if you could just do it programmatically? We're developers. We like doing things programmatically, and that's what SDKs, especially cloud SDKs, help you do. Currently, I maintain Pyrax, which is the SDK for OpenStack clouds. And it's open source. You can go to the Rackspace org on GitHub and download it and contribute if you'd like. The other thing is it's supported by Rackspace. So if in the future, let's say I win the lottery or meet a beautiful woman who wants to, is rich and wants to take care of me, and I decide maybe I don't want to work on Pyrax anymore, it'll still be supported. And it's not my pet project, let's put it that way. It's not going to be abandonware. All right, so we said, let's see some code, because we got this thing running. It's going along. With any luck, it will finish during our time slot, but I can't always guarantee that. Building on the cloud is way faster than actually ordering hardware and racking it up and wiring it together and all that, but it does take some time. So let's see what this code looks like. First thing you need to do is authenticate. So Pyrex uses a keyring auth as the preferred method. If you're not familiar with that, you store your keyring and the OS, your password, your credentials in the OS's keychain. And then this way your sensitive information is never stored in plain text anywhere on your disk drive. You can, if it's not super critical, store it in a credential file and pass that path to Pyrex, or if you're just hacking away, pass the credentials directly. All of these will work and do the same thing, just your taste. Credential files, they support straight OpenStack Keystone authentication or Rackspace Cloud authentication, and it's just a standard config file. The config file itself is another standard config file. What this does is it offers different environments for each configuration section. So when I develop, I have my default Rackspace account, and then I have a plain OpenStack installation on DevStack, and you can set up all the parameters. These are all in the doc, so I'm going to try and save some time by not discussing all of them here. But the nice thing is just by setting the environment to one of your different sections, now you can work on a completely different cloud. The code I have has a bunch of shortcuts because I'm lazy, and just all the different modules supporting the different cloud services that are available. So you'll see these abbreviations in the code. All right, let's start by creating the database. The first thing you do is you're creating an instance, so you call clouddatabase.create. Pretty simple. Pass a name. Flavor is basically a RAM configuration. Volume is number of gigabytes, so this will create a 2 gigabyte instance. Now this is the part that is important, is that these resources, when you create them, it takes time. It's done asynchronously. As soon as you make that call, you get back an object, but it's incomplete. It's in a build status. You'll have the ID, the name, some basic parameters about it, but you won't have enough to be able to work with it yet. And that's what this thing here is doing. This is the wait for build. It's doing the current status. If you look up, I can't read, way up there, you see it finally hit active after about 2 minutes, and then now that resource is available for you to work with and to manipulate as you wish. So by default, this is a blocking call. You can also pass a call back in and make it non-blocking. So if you have something that can happen asynchronously, you can just send that off in a non-blocking manner. So once that resource is built, you can create, this is a MySQL cloud database, so you can create a database on the database instance, and then create a user with access to that database. All right, in that application configuration, we have all our app servers working behind the load balancer, so they don't need access to the public internet. You actually don't want them to have access to the public internet. So you can define a software private network, give it a name and a CIDR, and just call cloudnetworks.create, passing in that information. Oh. You didn't? I just stepped on a wire. That's a weird coincidence. Anyway, so you can create this private network inside of your deployment. Another thing is you can store your public key in the cloud, and then when you create the servers, pass in the key name that you use. So like here, I'm opening up my public key file, giving it the name MacBooks, because I know when I'm deploying from here. And every server I create, when I pass that up, will automatically have that key in the authorized key files for that server, so I don't have to use password authentication to access it. Okay, now this is the part. This is app image. I hard-coded this particular ID because I created a server. What I did, this application isn't really that awesome. It just returns the local IP address for the server and the date and time, just to show that it's a different server that's responding. And I took a snapshot, but I had Apache configured. I had all the, Flask and all its dependencies installed, and I made a snapshot of that. And so here's where I create the servers. The only difference is the name of the server, but they're getting the same app image, the same flavor. That's, again, the size configuration. I'm passing in that key name and the network that I described, and creating 2 servers. Whoops. and then waiting for them to build. That's where this script is probably, oh, it already finished, great. I was dissing the network before, and and I shouldn't have. All right, so now here's where we create the load balancer. First thing we do is we get the local addresses from the 2 servers we just created. We define nodes, and that's what the load balancer uses to figure out what it's balancing. And you can give them different weights. So this is actually really good if you want to do A/B testing or something. You can give different weights to things and see which ones perform differently. A virtual IP, basically if you want it to face the public, you define it as public. This is not that interesting. But anyway, then here's where you create the load balancer. You give it a name, you define the port and protocol, you pass in the nodes that you want it to balance for, the IPs that you're going to be using, and an algorithm. In this case, it's a weighted round robin, so it'll just allocate the requests according to the weights of the different nodes. You wait for that to build, and now you grab its address once it's built. That address is one of those things that isn't assigned until the thing is actually created in the cloud. And last, I took the domain name pyraxdemo.com. I created a DNS domain with my information in there. Created an A record with the load balancer's IP address in there. And then added that to the domain. And that's it. That little diagram I showed you before, I just created that all in Python. And if you look here, so at the end here, I have the, you know what, let me bring that up so you guys in the back can see. So I have 2 local addresses for the servers and then the public load balancer IP address. Now, I don't think the DNS would have propagated yet, so let's just put the load balancer in there. And if you can see, it returned an IP address and the date and time. And let's just see, so 1.103, and you see that's server 1. If I redid this, it usually gives the same one because I think the load balancer's cache IPs. But if any of you can hit that from your device or whatever, you'll probably get either the 103 or the 215 there. And well, that's it. So I just created a server, 2 load balance servers. Let's just see if the DNS came through. No. Oh well. If you give it like 5 minutes, I'm sure it'll work. All right. So that's it. If you have any questions, you want to pass the mic around. Felt like I was going on double speed on that.
Hello. Yeah.
Yeah.
Thank you for the talk. And I guess just a quick question, since you are working on something community-facing, so maybe do you have any insights on how to specifically, I don't know, expose any API advice basically on maintaining such projects facing a large crowd of developers?
To say that just again,
basically having some better API guidelines for something community-facing to enhance readability and usability.
Okay, so basically taking the API as defined by OpenStack and making a better one? Like
no, essentially APIs of your library, I mean.
I guess I'm not following what you're asking. I want it public-facing. I want people to, if they can suggest an improvement, I'm more than happy to make it better. So.
No, I was just asking if there were any specific things that you've discovered in the process.
Oh, yeah, sure. Because one of the best things I think about developing in the open with other people looking is that you get another set of eyes or another few thousand sets of eyes looking at your code, looking at your approach. And the way that you use something typically reflects the things that you've designed in the past, the projects you've worked on in the past. Then you get somebody who says, oh, I'm using it to do X. And you go, wow, I never even thought of that. And now you can see how working on something like that, maybe you can make the API a little more flexible in this way, or make an option that didn't occur to me in the first place. So to me, I think the thing is that you can't anticipate every possible use case. So getting feedback from users by developing out in the open is pretty much the only way I know that to really make your SDK in this case, or your project's API as useful as possible.
Question? Yeah.
So there was a step there where you create a database. Is that creating a database in MySQL and Postgres? Or is it creating a database server?
Yeah, right now the Rackspace Cloud databases only support MySQL. There are plans to add Postgres. They are working on that now, and there's also MongoDB is being worked on, but I have no insight into delivery dates, and I don't promise things like that, but those are definitely in demand. I think MySQL was the easiest one, so they got that going real fast, and now they're adding additional. So.
And what about the load balancer? Is it Nginx, or what is the load balancer?
I'm sorry?
The load balancer that you are deploying, do you have
Under the hood, I'm really not sure. It could be HA proxy for all I know. But yeah, it's a cloud load balancer, so I'm sure it's software defined in some way, but I don't work on that, so I'm not sure what they do.
Any other question?
No.
No? Thank you, Ed.
Thank you.